Okay. And with that, I will go ahead and pass this over to our esteemed guest here that we are going to learn so much from today. Thank you so much for being here, Nimrita.
Thank you, Lindsay. And hi, everyone. I'm so excited. And it's interesting to see so many people from so many different countries, all interested in learning about NLP. I'm sure a lot of this enthusiasm is fueled by ChatGPT doing marvelous things around the world last few weeks. So looking at that, I have introduced the introduction to ChatGPT and how it works in today's class, today's session, and will continue with this in coming 3 weeks also. So by the time we are done in 4th week, we'll try to build a small language model of our own and try to replicate a small mini GPT for us. Right. So with that, I will share my screen and I will get started. Lindsay, can you confirm that my Jupyter notebook is visible to everybody? Yeah,
yes.
Now it is. Yeah. Great. So everyone, this is a session on introductory natural language processing. We'll have a bird's eye view of the entire field, and we will also get introduced to 2 Python libraries for natural language processing, NLTK and SpaCy. This is a 4-part series, so I have used an approach where we get gradually introduced and then we do hardcore NLP things, and finally we proceed on to a little complicated concepts and a little complicated tasks, and we end with actually building a small application for ourselves. So here's a set of references. You all can go to these links, check out details wherever you feel like you need extra information on the topic we speak about. For today's session, the agenda is introduction to the field of natural language processing and the libraries NLTK and SpaCy. So a little bit of Python familiarity. I'm assuming that the participants are familiar with coding with Python, and a few concepts from data science and machine learning will also be a great plus if you are aware. But if not, it's okay. You can let me know in the chat, or somehow you can communicate and we can elaborate on those concepts also. All right, so natural language processing deals with natural language, as the word itself says. Natural language is the language we humans use to communicate with one another. Languages like Hindi, English, German, Spanish, Hebrew, Arabic, and so on. Now, this natural language not only exists as written text, it also exists as spoken speech, or videos, audio, spoken text, and things like that. And I'm sure we all have used all these applications, all the internet, Facebook and TikTok and Twitter, and we all use Google. We watch videos, we create videos on TikTok, YouTube. A lot of internet data which comes from social media interactions among the humans exists as a natural language, either spoken or written. Then this natural language data also comes from a large corpora or large collections of text, which is available online for research purposes, for academic purposes. Then there's a lot of text data which is made available to us over the internet. For example, Google Books or Project Gutenberg, where you have open access to a lot of books which are out of their copyright period. Then there is Wikipedia, there's Wikidata, and there is data available at government of, all the countries' governments have a site, data.in or data.gov, where you have a lot of data shared with general public. There are also academic universities which provide data to the populace for research or for the analysis. So there's a lot of data, and if we are able to apply machine learning, deep learning in particular to this data, we'll be able to reveal a lot of hidden information, a lot of insights. And it is this hidden insight that is being trapped by e-commerce companies, for example, to show targeted ads to you, or to recommend specific products to you that might be that might have a high probability of you purchasing them, and so on. And of course, we have all used Alexa or Siri, or at least OK Google. And that's a fantastic application of how computers or software can, understand text or spoken word in a human language and respond to us in a human language. So this was about natural language or human language, the language we speak and understand and communicate in. Now, natural language processing is a computational linguistics field, which means it is a computer, it's a technology. So natural language processing, or NLP, is a branch of AI, artificial intelligence, which involves application of machine learning algorithms, statistical analysis to natural language in order to inculcate in computers an ability to understand the natural language and respond to us in a natural language. This obviously has a lot of advantage. You don't need to be a programmer. You don't need to code in specific, high-end computer language. You can speak to your computer. The computer can respond in a language you understand without having to, code and use a programming language. So what is the problem with that? Our language is so full of ambiguities. We are having a look at the image here. I saw a duck. A duck here can mean two different things. I'm sure there will be more meanings, but at least these two meanings are there. There's a girl who's trying to duck the football, and here's a person seeing a duck. Another sentence, this chicken is ready to eat. Are you trying to eat the chicken, or is the chicken waiting for a dinner to be served? So human language or natural language is ambiguous. For a computer to understand a command, we somehow need to make sure that it's unambiguous, right? It's a machine after all. Here's a funny example of a person communicating with Siri and Siri misunderstanding what the person wants her or it to do. So Siri, here's what person says: Siri, I'm bleeding really bad. Can you call me an ambulance? And Siri understands something, and she says, okay, from now on, I'll call you an ambulance. I'm sure the person didn't want this to happen, right? So it's very important that computers receive an unambiguous command. But when we are interested in giving them a command in natural language and human language, it's just not possible. So a lot of pre-processing comes into picture, which is used to recognize the actual intention, actual meaning behind what the person wants to say when he or she uses natural language to command a computer. Similarly, when a computer is responding to the human in a natural language, the computer also wants to, needs to make sure that the response is context aware. The response is actually what the human user wants to have. So for handling these ambiguities, making the human language meaningful to a computer and to bring it into a understandable form involves a large number of tasks, a lot of tasks. We'll be looking at a few tasks now. The first task that is generally done in every natural language processing project is tokenization of the task. Tokenization means splitting a sentence, splitting a paragraph, or splitting a large document into smaller chunks. You can split a document into paras, a para into sentences, a sentence into words, and then we can have punctuation separated. So all of this helps us to break down a large piece of text into smaller words or smaller punctuation marks. The next processing step that we apply to the text is normalization, which generally covers case conversion, bringing all the text into small case or bringing all the text into capital case, then removing some words which do not add much of the meaning to the text. Words like to, but, yet, which occur very, very, very frequently. I'm speaking in the context of English language. I'm sure there are stop words in other languages also, which are used too frequently and don't add much meaning to the text. The further steps in normalizing your text are stemming. Stemming means we want to we just strip off the text, the words of their suffixes. For example, for words like played, play, plays, we'll just drop the suffixes and just take the root form play. Then we can do something called as lemmatization, which again refers to the process of bringing words in their lemma forms. The lemma forms are the words we find in dictionary, the root forms. Once we have done these things, we somehow have to figure out a way of converting this text into numerical vectors, because that's what our machine learning algorithms can work with. That's what computational algorithms can work with, the numbers. So there are multiple ways, there are multiple techniques by which we convert text into vectors of numbers. We'll be looking at these techniques in second session on coming Thursday. After this, there are lexical tasks which help us to find the meaning from the text. And these tasks include part of speech tagging, or identifying what is the grammatical class of the word. Is it a verb, a conjunction, an adjective, an adverb, and things like that. Once we have done this, we are a little bit closer to understanding that text. This also includes identifying relationships between the words, relationships like subject-object relationships. The next task we do is sense and disambiguation, of finding the intended meaning of the word, and it depends on the context of the words which are towards which follow the current word of which we want to disambiguate the sense, or which precede the word that we are interested in disambiguating. For example, there's a sentence called, I made the grade, which means I achieved the grade. And there's a sentence, I made a bet, which means, I placed a bet. Both sentences have the word make, but in first sentence, the make word has a different meaning. In second sentence, it has a different meaning. So we have to have some way of making the computer understand what is the meaning of this word in current context. By context, I mean the neighboring words. The next task we do generally is named entity recognition. A named entity is the name of a person, a geographical location, a company, for example, some currency, a mobile phone brand. These are named entities, and there are techniques in natural language processing which help us to identify these prominently named entities in the text. Next important task we do is disambiguating the pronouns, finding out to what entity the pronoun refers to. This is called co-reference resolution or pronoun resolution. So this again is a very important research problem in natural language processing. After this, we have some higher level tasks in NLP, which include tasks like sentiment analysis. Out of the text that is given to you, you wish to identify what is the subjective attitude of the writer or the speaker, what is the emotion carried by the text. For example, people have given reviews about some movie, and from the reviews, you want a computer software to identify for you, is the movie overall good for you to watch? Is it worth your time or not? Then we have the task of text classification. This means categorizing text into different categories. Suppose you have a news article and you want to classify it, whether this is news pertaining to entertainment, this is a news article pertaining to politics or finance, So, or you wish to classify some email as a spam email or as a good email automatically. This depends a lot on presence of specific words, which will be called features, as we'll come to know in later part of this class. The words which help you to discriminate between different classes of text, the frequency of words, or actual presence or absence of certain words. Next task we have in NLP is speech recognition, which means to automatically identify that this is the human text and converting that into a text data in a SpaCy text or in a computer generated text. This has a lot of complication because people differ in their speeds, in the way they use emphasis, their tones, their accents, and so on. Next important task that NLP involves is natural language inference or entailment, which means given two pieces of text, you need to decide, the software needs to decide, can we infer the second piece of text from the first piece of text, right? That means you can let go of second piece of text if the information contained in second piece is already present or somehow inferable from first piece of text. Then we have the task of natural language generation, for which the ChatGPT is so good, generating response to human queries and questions, all in natural language. It includes a lot of steps, a lot of planning, a lot of natural language understanding code, a lot of language modeling, as we'll see as we proceed. So the last task that we are looking at today is language modeling. This is an unsupervised task which does not involve supervision from a human expert. And here we use probability distributions in order to predict what will be the best word after the current sequence of words, what word should come next. So having looked at some of the tasks that we do or that we need to do during NLP project, we'll look at some of the use cases of NLP. We have a huge application of NLP in cybersecurity, which includes threat identification, fraud identification, spam email spam classification, then identifying inaccuracies in some text or something which is inappropriate. The second very important task we have is machine translation, which is a great application of NLP. I'm sure we all have used Google Translate or Microsoft Translate. Yeah. And then we have conversational AI, which includes virtual assistants like Siri, Alexa, and the chatbots. I'm sure we have used a chatbot to interact with the company, where it answers all our questions or helps us make appointments, helps us make reservations for airline tickets, things like that. We also have a very good application in question answering systems, where you can ask a well-formed question, an expected question, an unexpected question, not so well-formed question, a vague question, and the software is able to answer you, and with a decent level of accuracy and satisfaction of the user. The next task we have, the next application of NLP is social media sentiment analysis. We have seen that this has a huge implication in e-commerce, in politics, in governance, where the government or a company needs to have a grasp on customers' feelings and attitudes in order to predict, what may happen. So where should they focus on? Things like that. Another application of NLP is in text summarization, or creating summaries, synopsis out of big documents. I was working with my PhD group last few months, and a lot of students now, instead of reading the papers and summarizing them on their own, they just want a NLP application which will create brief summaries of the papers for them, right? So that they can focus on something else, or they can read more number of papers now. So text summarization is a great application. Then we can use NLP for generating captions for images. We have already seen last few weeks, last month, the GPT-3, which is a large language model, a pre-trained transformer, and a language model for a long list of languages from all over the world. These large language models can be used for machine translation, optical character recognition, generating natural language. They can be used as chatbots. They can be used as customer service bots. Then we have an application of NLP in autocorrect, automatically correcting the spellings or suggesting you the right spelling of the word, correcting the grammar while you're composing your emails or writing your documents in Microsoft Word. I'm sure a lot of us have used the autocorrect feature of Gmail. We have autocomplete, the suggestions you get while typing a search query in Google's search box. Sure, other applications also use autocomplete. Then we have semantic search, which is context-aware search. Basically, you're not just doing a keyword search with search engines like Google or Bing. Your search is actually context-aware, right? The search engine actually makes sense of in what context you are looking for that search term. Then there's a huge application of NLP in healthcare for converting prescriptions written by doctors into text or voice. It's really common that the prescriptions that doctors write are unreadable a lot of times. So this application has a huge potential to be used in a big way in healthcare. They are also the NLP applications are also being used for automatically documenting health records. And then there is application in trial matching, phenotyping, and so on. in finance and insurance sectors, NLP tools are being used for credit scoring, then for checking or evaluating insurance claims, for creating reports and auditing the financial reports. Same way in HR, we are now going to use, I'm sure some LinkedIn and all, they're already using NLP tools for automatically summarizing resumes, automatic resume matching with the job description based on phrase extraction and keyword extraction, then creating transcription for videos, doing a sentiment analysis on employees and so on. The last application we look at today here is the market intelligence, which means we use web scraping or sentiment analysis to identify current marketing trends and then fine tune or optimize our own strategy to meet the market requirements or to keep our profits high. Since this is focused towards computational aspects of NLP, I want to dive right into the machine learning aspect and coding aspect of it. So the machine learning models that were conventionally used for NLP are Bayesian algorithms. Then we have decision tree, which is used a big way in NLP. There are support vector machines. We also can use other algorithms by doing appropriate embeddings of the text into numerical forms. But last few decades, deep learning architectures have done extremely well on NLP tasks. The recurrent neural networks, then LSTMs, by LSTMs, even CNN, and 2015 onwards, transformers have done really very great job with NLP tasks. These are a few deep learning models which have been very in news and very popular with their performance in NLP. Google's BERT and then ChatGPT 2 and GPT-3. I'm sure it needs no introduction from OpenAI. There is ExcelNet, there's T5, there's Palm again from Google, which are very popular, and they're doing great things with conversational AI and question answering systems and machine translation tasks and so on. So coming to Python, Python has not just two, it has many libraries, many advanced libraries for supporting your projects in NLP. NLTK is the first one, very extensive library, very useful for your research work. Then there is a SpaCy, which again is built on top of NLTK. It also provides you the built-in pre-trained models for around 72 languages. There's a library called TextBlob, again built on top of NLTK and has built-in support for a lot of NLP tasks. Gensum is another library. We have Polyglot, which supports 196 languages. And then there is sklearn. Of course, sklearn is the bedrock for machine learning. Any machine learning practitioner, sklearn is a must in their skill set. We also have deep learning libraries like PyTorch, TensorFlow, and Keras, which are very important when you are implementing your projects using deep learning. So in the remaining part of this session, we'll be looking at libraries in NLTK and SpaCy. Assuming almost zero background in NLP, we are going to start with the first steps, installing these libraries, and then installing the required data or corpora, and then seeing how to do the simple steps, and then we'll go on and do complicated tasks also. For these library.
I'm sorry, could I go ahead and I'm so sorry to interrupt. We do have a request to zoom in if it's possible on the notebook. And I feel like I just wanted to do that right now because as we start getting started so people can see. Thank you.
Yes. So shall I look at the questions, or how do we do this?
So there was just a request to zoom in on the notebook if it's possible. Just from your browser. Maybe you can.
Shall I share the GitHub link?
Oh, that would be fantastic. Yeah, we were going to ask you about that as well.
Yeah.
Great, thank you. I know our guests will super appreciate that.
So I'm here sharing the GitHub link to this Jupyter notebook, complete notebook, and the images and everything are there.
Much appreciated. Thank you.
I should have done right in the beginning, but anyhow, it just skipped my mind. Is that fine?
Yes, we got it. Thank you.
And so, as I said, we are assuming, I am assuming that the audience here are familiar with programming in Python, and they know how to install Python, how to write small codes in Python, how to write functions, and how to call those functions, how to assign values to variables, and so on. So familiarity with Python is a prerequisite, and if it's required, we can have a session on demand where we get started with Python also. But for this session, Python is a prerequisite. So we can have native Python installation on your machines. We can also have Anaconda Python, which is the preferred way of doing Python for all data science and machine learning and NLP related projects. Having Anaconda Python installed on your machine is way better than having just the native installation. So once you have Python, Anaconda Python, and Jupyter Notebook installed on your machines, we will install NLTK, which stands for Natural Language Toolkit. You can install it using pip, or you can install it using Conda. Pip and Conda are package managers for Python. If you have native Python installation, the way for you to install NLTK or any library is the command pip. Pip install NLTK. You need to run this command at your command prompt. If you are using Anaconda Python, the command for you is conda install NLTK. This takes a few seconds. And once the installation is done in our new Jupyter notebook, we need to first import NLTK into our workspace. That is done using the keyword import followed by NLTK. NLTK is the name of the library or the module. And then you need to download a certain set of data sets which we would be demoing today, or which you would use in your projects. This is done with the help of nltk.download command. When you run this, you'll get a separate browser window which lists a lot of data sets. Data set in NLTK is called a corpora. So you will see a list of available corpora in NLTK. Select which ones you are interested in, or you can select all of them, right? It takes, maybe 1 minute to download all the corpora to your machine. Once you are done with installation of NLTK and you have downloaded the data sets, we are good to go. We are good to execute the further steps in this Jupyter notebook. Now, what are the functionalities? What are the tasks that you can do using NLTK? You can access the corpora which come with NLTK. You can also access corpora over the internet. You can access your local corpora which reside on your own machine. There is a module corpus for that, and it provides you standard interfaces for handling corpora, for reading corpora, for interacting with both corpora and their vocabulary, the lexicon. We have built-in functionality for a lot of string processing, tokenizing your text, lemmatizing, then stemming the text. We have built-in functionality for identifying groups of text, which are called collocations and bigrams and trigrams, n-grams in general. We have built-in functionality for tagging your words with their appropriate grammatical class, which is called POS tagging. There's a built-in functionality for machine learning algorithms. There are algorithms to classify your text, to cluster your text. Then we have functionality for chunking, grouping your text based on certain patterns. We'll also be looking at, during your NLP projects, you'll also come across a lot of regular expression related programming. So it'll be a great help if we familiarize ourselves with how regular expressions in Python work and the RE module in general. NLTK is also used for semantic interpretation of the text, understanding the meaning, inferring the meaning of the text. And then there is a built-in support for evaluating the performance of your text classifiers or your clustering algorithms. And there is then a built-in module for identifying probability-related matrix and your estimation-related matrix. We can build applications using NLTK. a chatbot or any other kind of application, a parsing application, then we can do a lot of linguistic work with toolbox and shoebox lexicons. So here onwards, I'm going to demo the basic tasks of tokenization, POS, part of speech, tagging, stemming, and lemmatization. As we do the code, as we see the code, we will also try to understand what that task is and what it is actually doing to the text. So here, this is a Jupyter Notebook cell, a code cell, where we can write the executable Python code and run it. So in this cell, I have imported NLTK.corpus, which means I am trying to load all the text corpora which come with NLTK into the current workspace, into this Jupyter Notebook. And especially, I'm going to look at the brown corpus. NLTK comes with a number of text corpora. A number of these text corpora are pre-tagged, which means there's not just the text, there is also text, there's also annotations with the text. These annotations include the POS tags, parts of speech tags for this text. There are also parse trees for entire sentences in some corpora which are in NLTK. So in short, if you are pursuing your project, let's say if you're pursuing your thesis, a master's thesis, or even an undergrad thesis, and you're trying to build an application, you're trying to train your own classifier using NLTK. So built-in corpora is a good resource to look at. Instead of looking for text data outside, built-in corpora can also be a pretty good resource for such projects. So we are looking at Brown corpus, which is a text corpus coming from Brown University. Corpus name dot file IDs helps us to see the list of files which are present in this corpus. Corpus means a body of text, a large collection of text. Within this collection, the text can be organized in the form of individual files, or it can be present as a single chunk. Most of the corpora in NLTK are separated in separate files. Each file has a file ID, and corpus name.file IDs function helps you see the names of those files. The file IDs are displayed for you here. So a lot of files there. Then we can see the file IDs of a different corpus, which is called tree bank. Again, it has a lot of files with extension .mrg. You wish to see the contents of a file. For that, the function name is called a raw, or you can even use the function words. So it helps you to see the content, the text content of a file. In this case, we have used NLTK.corpus module. From that, I have imported a corpus called inaugural. Inaugural corpus contains the text of inaugural speech of US presidents, from 1789. Inaugural speeches of US presidents. So this is the speech of 1789. I think I just don't know who is the speaker, but this is one of the files by one of the presidents in 1789. And here's the content of this file. You can look at the words in the form of a list of this file, which is in the inaugural corpus. By using the words command, words function, you can see the sentences within a corpus by using sense function. You can see even the paragraphs by using the paras function. So this helps you to analyze your corpus. What is there in your corpus? How big is the corpus? What is the size? What is the number of words? What is the number of sentences in your corpus? What kind of data is there? Do you find any deformed words or the words with misspellings? A preliminary analysis of your data set. We also have data sets in NLTK, which are not in English, which are in multiple languages from all over the world. For example, this is Indian corpus, where you have the words and you also have the tagged words. By tagged words, I mean there are POS tags associated with each word. So in this, we are looking at tagged words in the Indian corpus, simple words, and the words with their tags. Here we are looking at the tagged sentences in Brown corpus. So this is a list, which means the sentence is displayed to us, represented to us in the form of a list of words. With every word, we also have its POS tag. By POS tag, we mean the grammatical class of that word, whether that's a noun, whether it's an adjective, whether it's a verb or adverb, a conjunction, a determinant, and so on. Next, what we have in NLTK is a list of words, a special kind of words, and there are certain lexicons. For example, there are stop words in every language. The words, we already spoke about this. Stop words are the words which are very, very commonly used in spoken or written text. Words like to, but, yet, who. And such words do not add much meaning to the sentence. And usually during our NLP projects, we just filter them out. We just remove them from the text before proceeding with text analysis or before feeding our text to the machine learning algorithms. So here we are looking at a special corpus in NLTK, which is called words. It is a set of English language words with correct spellings alphabetically arranged. So from NLTK.corpus, we import the words corpus. And in Word, we are looking at the file IDs. There are two files in this corpus. One is called, it's for English language only, English and English Basic. Next, we are printing here first 100 words from the words corpus. The words function gives us first 100 words. Why first 100? Because I'm here giving an index value, which lets me see only first 100 words. It's a huge corpus, right? There's a lot of words in this. So I just did not want to print all of them here on the Jupyter notebook. So first 100 words in the form of a list, which is the outcome of words function. Then first 100 words, which is an outcome of raw function displayed in the form of a list like this, all alphabetically arranged. Next, we are going to see the stop words corpus. Stop words is a built-in corpus. You need to import it like this from nltk.corpus, import stop words. And all of these names are case sensitive, right? The names of corpora, you need to use the same case in which they have been defined. Stopwords.file IDs. This stop words contains, stop words corpus contains the stop words of all these languages, Arabic, Bengali, Chinese, Dutch, Turkish, and so on. So for all these languages, all the stop words are there present in this corpus. There's a corpus called names in NLTK. It contains the names of commonly used names of male humans and female humans classified under two files, female.txt and male.txt. So female.txt is basically a collection of all the commonly used female names. Male.txt is a collection of commonly used male names. So this corpus we can use to build our own a small NLP application which can identify whether the name you give it is the name of a female or name of a male person. So here are some of the names in male.txt, Amir, Abby, Abbott, Abdul, and so on. Similarly, there are a lot of names. It's a long corpus. In the female.txt, we again have a lot of names which we can see and which we can use for our building our own projects. Then in addition to corpora, we also have lexicons built into NLTK. How is a lexicon different from a text corpus? A text corpus generally is a set of words, right? It's text. And sometimes this text can also have annotations, POS tags, or parsed sentences. But a lexicon is a set of vocabulary. It's a vocabulary for a language. Vocabulary means the unique words present in that language without repetitions, which are called lexemes. So a lexicon contains the lexemes, unique words in a language. In addition to these words, you may also have in a lexicon different words, different word forms, like a noun form, adjective form, a verb form of that word. It's synonyms or antonyms as well. There's a built-in opinion lexicon in NLTK. Opinion lexicon can be imported into your Jupyter notebook by using from nltk.corpus, import opinion lexicon. Again, it has files containing data, data containing words which indicate a positive opinion and words which are indicative of a negative opinion. We can use this lexicon to build our own small module for sentiment analysis, to train our module for sentiment analysis. Then in NLTK, we also have two corpora of reviews, product reviews 1 and product reviews 2. This corpora contains the reviews given by human beings for certain products like a Canon camera and so on. These reviews are already classified into positive and negative categories. Again, we can use these built-in corpora to train our own sentiment analysis or product review classifier modules. Next, we'll be looking at simple tasks using NLTK. So tokenization first. To do tokenization, tokenization means to split your text into its constituent parts, to break a paragraph into sentences, to break a sentence into words and punctuation marks. So for doing this in NLTK, we have word underscore tokenize and sent underscore tokenize functions. We import them from NLTK module. So the import statement I write is something like this: from NLTK import word underscore tokenize, comma, sent underscore tokenize. And then we define some sentence which we wish to be tokenized, which we wish to be split. Here is the sentence, some text. And then we apply word underscore tokenize on this and we print the output. Then we apply sent underscore tokenize on the sentence and we print the output. This is the text we want to be tokenized. This is how you call a function, word tokenize on it. And this is how you call function send tokenize on it, and we print the outputs, right? So here is the word tokenizing output where I have every single word separated for me in the form of a list. And this is the output of sent tokenize, which breaks the sentence into, which breaks the text into separate sentences, which are separated by punctuation marks or full stop. Here we look at the stop word removal task. For that, we first load the module stop words, we define some text, and then we figure out which languages stop words are we interested in. Since my original text is in English, I want to remove the stop words of English. So I'm loading words from English stop word set. Then we tokenize our sentence, we split it into words. Hereafter, I have the task of removing stop words. For that, we define an empty list called cleaned tokens. Then inside a for loop, we are checking every word. If it's not in stop words, then we are going to retain it, else we'll just filter it out. So clean token is appended with the word. If that word is not present in the stop words list, then we can print the original version of tokens with the stop words included, and we are printing the final version of tokens with the stop words removed. So here is what I had earlier before removing the stop words. I will pick you up at 5 p.m. full stop. We will go for a walk. So I is retained, will is dropped, pick is retained, you is dropped, up is dropped, at is dropped, all the essential words are retained, and the commonly appearing words will, at, these are dropped. That's what is the meaning of removing stop words. Stemming and lemmatization. Stemming means removing the suffixes, and lemmatization means bringing the word in its root form, in its lemma form. Both sometimes look similar. Both the tasks sometimes lead to similar kind of output, but there's a difference. Lemmatization is more of a compute-intensive task, and it uses morphological analysis, semantic analysis of the sentence. It looks at the context of the sentence, context of the word also. What are the words before it? What are the words after it? So computationally expensive than stemming is lemmatization. How do we do stemming in NLTK? You can write your own stemmer, as we will see in next class. You can also use the ready-made stemmers in NLTK. One such stemmer is Porter stemmer. You import it from nltk.stem and you can use it. First, you need to create an object of Porter stemmer and then use it to stem your text. For example, here I'm using Porter stemmer to stem the word feet for me. And the result is feet, right? It does not have any suffixes, so the output is just like that. Here we have applied Porter stemmer on a list of words: play, playing, plays, played, playfulness, and playful, right? So playing is the basic word or the stem of the word, and here it has a suffix ing, here it has a suffix s, here it has a suffix ed, and so on. So using a for loop, using a list comprehension and a for loop, we have applied stemmer.stem function to all the words in this list of words. And here's the output we see. So for play, the stem is play. For playing, the stem is play. For plays, the stem is play, right? So we are basically dropping the punctuation marks. Next, we see lemmatization. For lemmatization, we are again seeing the built-in lemmatizer, which is called the WordNet lemmatizer. You create an object for it and you just pass it the text that you want to be lemmatized. See, for the word feet, the root word is foot. So we get it as the lemmatized form of the word. Here we are applying lemmatizer on a sentence, which is a string SENT. We can see that hands has been lemmatized to hand. Similarly, feet has been lemmatized to foot. There is support for pause tagging or part of speech identification in NLTK. It has a built-in module called pause_tag. You have to import that module. You have to import the stop words library. Then we want to figure out which language the text is. For the same language, we want to remove the stop words. So stop words of English language are there in this variable stop_words. We initialized some text from which we will remove the stop words. Before that, we will tokenize this text. Again, we saw this code above also. We cleaned the code, we cleaned the text of the stop words, and then we pass it to pause_tag function. And the result is tagged text, which means for every word of the text, you will have the corresponding grammatical class, a noun. NN stands for noun, DT stands for determiner. Then these special brackets or full stop retain the tag as it is. Noun, you have a verb form here. You may have a conjunction or an adjective. Then we can do named entity recognition in NLTK using NLTK.chunk module. And there's a function called any_chunk, named entity_chunk. You can pass your tagged text to any_chunk function and tells you if there's a special named entity in the text or not. NLTK provides a huge thesaurus or a dictionary of English language, which is called WordNet. WordNet arranges words in the form of synonym sets or synsets. For every word, you have a synset, which includes not just the word, but also the words which are similar to this word in meaning. You can use WordNet to build a lot of applications for yourself. Again, the WordNet supports not just English. I mean, a lot of other languages also. There are at least 25 other languages which is supported by WordNet. And there is a movie reviews corpus in WordNet, which helps you to build a classifier for movies. We are seeing a small complete application here for building a movie, identifying whether the movie is good or bad using NLTK. We imported here NLTK. I also imported the string module of Python. Then I am using the send tokenize and word tokenize functions for tokenizing text. I'm also going to remove the stop words. So I have imported stop words, and I have imported a corpus called movie_reviews, which contains the reviews given by actual human users classified as positive reviews and negative reviews. It contains two files, positive reviews.txt and negative reviews.txt. We are reading those two files, the negative files and the positive files in these two variables. In the feature extraction function, we have first removed the stop words. We have also removed the punctuation marks, and then we are returning all the words except the stop words, except the punctuation marks. Then we apply this feature extraction function to every word within the negative reviews file and within the positive review files. So what we have here are all the negative words, the words which are present in negative review files, and positive words, the set of words which are present in positive reviews, the files which contain positive reviews. Right. So here are the words which are present in negative files: nightmares, girlfriend, dies, accident, harder, words like that. Then we have words which are present in positive reviews files like words like plenty, success, superheroes, Batman, really, and so on. And then we can use this to train a model of naive-Bayes classifier to predict for ourselves whether the review we are interested in right now is a positive movie or a negative one. That's a really long output. So here we have used naive-Bayes classifier. It is present in NLTK's classify module. So we imported from NLTK.classify naive-Bayes classifier. We created a small object of naive-Bayes classifier. We are training that object on first 500 positive reviews and also first 500 negative reviews. There are 1,000 reviews in all, both in positive file and in negative file. So out of those 1,000, we are using 50 positive reviews, 50 negative reviews to train our classifier. Once the classifier is trained, we can evaluate it for its performance on rest of the 500 reviews, which we did not use during training. So the accuracy of this classifier is around 79.6%. So pretty good, not very good, but okay. With the small data set that we have trained it on, this accuracy seems okay. And we can see what are the most common features, most informative features in this set of words. So we see that whatsoever is the word which occurs very, very frequently in negative reviews as compared to positive reviews. Similarly, the word inept occurs very frequently in negative reviews. Ludicrous occurs more frequently in 11.7 times more often in negative reviews as compared to positive reviews. The word nomination occurs more frequently in positive reviews as compared to negative reviews. Vulnerable occurs more frequently in positive reviews, and so on. So this was a brief introduction to NLTK library. Very, very quickly, I will speak about SpaCy and we'll take it up again in next session. And next session, we'll see more of the functionality of SpaCy in coming session. So SpaCy is built on top of NLTK, and all of these libraries are free and open source. It supports 72 languages. It has pre-trained pipelines for about 24 languages. And these pipelines come in different sizes, small pipelines, medium-sized pipelines, large pipelines, depending on how much data they contain, how much annotation they contain, what is the accuracy of the model they provide. Then it contains the vectors, the word vectors for a lot of words, for a lot of languages. You can install SpaCy using both pip and conda, depending upon what Python installation you are using. Once you install SpaCy, you again need to download the data set or the pipeline for English language or for whichever language you usually do your NLP projects. For example, here I'm downloading the pipeline of English language, en_core_web, and it is SM. SM means it's a small sized pipeline. What functionality does SpaCy provide me? It provides tokenization, it provides POS tagging, it provides me to analyze the dependency among the words, subject-object dependency, for example, then lemmatization, detecting sentence boundaries, named entity recognition, entity linking. We'll see what all this means in the coming session. Then identifying similarity between the text, classifying text, matching text based on certain rules, training your own modules for all these functions, and then serializing or storing your models in the form of pickle files. Out of these pre-trained models that we get with SpaCy, we get in these pre-trained models or NLP pipelines, the binary weights. There are neural networks which already have been trained on a lot of data. So those neural networks, their weights, the lexical entities, the vector representation of words, the data files, along with the text, the lemmatized forms, the rules, the lookup tables, all of this is given to you. So this is the general pipeline of an NLP project in SpaCy. You have some text, you first tokenize it, you apply POS, a tagger on it. That means you identify the grammatical class of the words. Then you can parse your text. You can do entity recognition, named entity recognition. You can do sentiment analysis followed by, you can do translation, you can do summarization, whatever you are interested in. So the first step in your program, if you're using SpaCy, is of course to import SpaCy into your Jupyter notebook. After you have imported SpaCy, you also have to load the pipeline you are using, you're going to use. That is done using spacy.load function. Pass it the name of the pipeline. For example, I'm using small sized English language pipeline here. The result of spacy.load function is a language object, which is generally named as NLP. This NLP object has all the functionality that NLP provides you, depending upon the model that you have loaded. Have some text, define some text in your program. For example, I have a simple sentence here in the form of a string. Apply NLP object to this text. It creates a doc object. This doc object is a collection of tokens in your text with their pos tags and some extra information. So here, using a for loop, I am printing all the tokens of this text, of this doc. Token.text means actual content, actual text of the of that token, then lemma form of that token, pos tag of that token, then dependencies, the shape of that token, whether that token is an alphabetical word or not, whether that token is a stop word or not. So here is the output for every word in my sentence. I can see whether it's a what is its POS tag, what is its termination, what is its relationship with other words, whether it's a stop word, whether it's alphabetical or not. So same way, the doc object contains entity information also. If there is any named entity in the text, it will show you by using the .ent attribute of document object. For example, Apple here is the name of a company, UK here is the name of a geographical location, and $1 is currency, is money. So here you can see Apple, it starts at index 0 or location 0 in the text. It ends at location 5 or index 5 in the text, and it's an organization. UK starts at index 27, ends at index 31, and it is a geographical location. Then $1 billion starts at index 44, ends at index 54, and it presents money. SpaCy has built-in support for visualization. So there is a built-in renderer. You can create your own visualization using DisplayC, which is a module inside SpaCy. So DisplayC.render will help you to represent visually all the dependencies, the relationships of subject and object within your text. You can see a graphical representation on here. All right, so that's enough of introduction of SpaCy and NLTK today. Closing the session on an interesting note about ChatGPT. ChatGPT is a large language model, which means it has the ability to determine, to find out what should be the next best word in my output, right? When I am communicating with a human user, what should be the next word I should use? It's a generator model, a pre-trained transformer, which means it already has a lot of text data that it has analyzed, and it has known and built relationships among those sentences. As an example, you're trying to search for something and you already see a list of most probable search phrases you are interested in. All right, with ChatGPT 3, we also have Megatron LM, right? And we have BERT and a lot of other models coming up every day from Microsoft and Facebook and all that. Right. So I hope we have been able to do justice, and in coming sessions, it's going to be more coding intensive. So brush up of Python will be a great help, I think. If there are any questions, we'll be happy to take quickly.
Wonderful. Yeah, we do have some really insightful questions here. Backing up a little bit over to the corpus. Someone was curious about what is a corpus exactly, and how are these corpuses created?
Yes. Corpus means a set of text data, a collection of text data. It can be a simple notepad file. You use Notepad to create a text file, or you use Word, Microsoft Word to create a file. It can be a text corpus, right? In machine learning in general, you have data in the form of a CSV file, or in the form of an SQL database, or in the form of, let's say you have data stored in an Excel file, right? In NLP, the text we have is called a corpus. It's another name for data set in text. And how are these corpus created? Of course, these are created when you speak, or when you compose some mails, when you write your documentation, when you interact with people through posts on TikTok, or Twitter and Facebook. All of this, when you write your blog post, all of this is generating text, right? When you download and store this text, a corpus is created. Maybe your PhD thesis, a collection of all the theses of a university, a corpus. Tokenization is only possible for English language. No, it's possible for all the languages, and all the languages have different rules in which they wish to, in which the sentences are broken into tokens. Can Beautiful Soup? Yes, Beautiful Soup is a library used for web scraping, downloading or extracting text from HTML documents from the internet. I'm glad that you found it interesting, and I'm sure we'll definitely have a hang of NLP tasks by the time we end. We'll have a small project that we build for ourselves. The best way to prepare for next week's is, what is the best way? The best way is to execute everything I have shared with you today in today's notebook. And if you feel a requirement to brush up on Python, then I think any Python tutor on the internet should be good enough. How to use functions in Python, how to use for loops, and how to use list comprehension in Python. Okay. I think there are no more questions. Thank you so much. I'm really, really glad that this was useful to you all. And we look forward to having a great session on next Thursday also.
Thank you so much. I'm very much looking forward to the next session.
A
lot of audience members as well. Right.
Thank you.
Everyone have a great day.
Thank you. Bye-bye, everyone.
Bye-bye.